Right, so shall we have a look like what we have done so far? So under the current electricity lesson, so we know that always if we take a circuit, right? If we take a circuit, an electric circuit, we know that there are some important components that we should know. Right? So always we are going to be talking about some of the like specific characteristics, some of the specific components in an electric circuit, right? So what are they? So one thing is going to be the current which is going to be passing through the circuit. We have to pay attention for the current. So usually we know I is the symbol that we are going to be using for current, and then how we are going to be measuring the current. We can use the ammeter for that thing, right? Ammeter is going to be used. And then we know how we have to connect the ammeter to the circuit, right? It has to be connected in series method, right? So then we discussed another component which is important in the circuits. It's going to be the voltage, right? So voltage, usually we are denoting it by capital V. And what is the instrument that we are using to measure the voltage? Voltmeter. Yes, voltmeter. And then how we have to connect that voltmeter in the circuit? Is it in the series? No, right? It should be in the parallel, yes, connection. So see, current and the voltage. So these two are very, very important in a circuit. Right, so these are the usual things that they are going to be having. So in order to give a high voltage, we can connect a number of dry cells if we want. So then we know the current is going to be starting from the positive terminal, isn't it? So then we are going to be indicating, if we want to indicate the current, the direction that the current flow, we can indicate with arrowheads. So always we are going to be starting from the positive terminal, the cell, right? So then it's going to be moving like this, moving through the bulb and then coming back again and returning it to the negative terminal. So that is the usual current flow, right? The current flow in a circuit. So always to occur or to flow or to occur the flow of the current, always it has to be a, yes, what we are going to be saying, it should be a closed circuit. If there is an opening, can the current pass through? No. Current flow will be stopped. So that's why if we want, we can insert a switch. So if we switch on only, then it's going to be acting as a complete circuit. But if we switch off, that means it's going to be disconnected. So then it's not going to be a completed one. So it's an incomplete circuit now. Right? Okay, it's not a closed, then it becomes an open circuit. So those things, hope you're having an idea. Right, so now see, we'll go back to here. Now we were talking about the current, voltage, and then we discussed what is the relationship between these two. Isn't it? So Ohm's, the scientist, he was going to be doing an investigation regarding these two, isn't it? Right? And then he came to the final conclusion, which is known as the Ohm's law. Right? So can someone tell what is Ohm's law? I think last week also I asked from someone, yes, what is going to be the Ohm's law? Yes, anyone? Ohm's law, how you are going to be writing? In the paper, it will be there. Ohm's law. Yes.
The equation.
I know how you are going to be stating. What is the definition? How you have to start. Something should be constant. What is it? When? Yes, when the temperature is constant, what we are going to be saying? The current passing through a conductor is directly proportional to the potential difference across a conductor. Isn't it, right? So from that, hope you can remember, we came to this we came to this conclusion. Current passing through the circuit is directly proportional to the voltage, right? And from that, how we are going to be detecting it if we do an experiment for this? Yes, if we are going to be drawing the voltage and the current, how they are going to be changing, right? We are going to be getting a graph which is going to be linearly increasing, right? So this is the graph that is going to be showing us the Ohm's law, where we can use to prove the Ohm's law, right? So regarding this, we discussed that in the last week. Okay, right. So then we discussed, so since I is going to be directly proportional to the V, can't we use an equation? We can, right? So then what's the equation we derive from this thing? V equals I R. So here, in order to like have an equation to do some calculations, so then the other scientists, they derived another equation. So that's known as V equals IR. So can I see now, here also the voltage is there, the current is there, and then what is the other component? This is what we call as the resistance, or yes, the resistance R. Right? So that means if we take a conductor or if we take a circuit, apart from the current, apart from the voltage, we can measure the resistance as well. Isn't it? So for that, there are like specific equipment that we can fix in this circuit. So here in this circuit also cannot recognize that there is a resistor that I have drawn. Can you all see? Can I recognize a resistor? Yes, the symbol? Yes.
Like
Can
that
you
wave.
Yeah, this thing. Yeah. So this is going to be a resistor. So see now, apart from the bulb, apart from the dry cell, here there is another component. This is what we call as a resistor. So then resistor means what is, so if you take the function of it, what's it going to be doing? It's going to be, yes, restricting the current flow in the circuit, right? So usually if the resistance is high, we are saying the current which is passing through the circuit is less. So always we can say that R, if the R is high, if it's going to be having a higher value, the current passing through the circuit is less. So that means always these two acting oppositely. They are indirectly proportional. Isn't it? I and R. See, if R is high, current, the amount of current passing through the circuit is less. Right? So then regarding this, we discussed if we take the conductors that we are using for a circuit, also we know if its resistance is very high, usually the current passing is going to be less. So because of that, we are using which kind of conductors? Copper conductors, isn't it? So because their resistivity is less. Because the conductors also going to be having a certain resistance. Right? Okay, so always remember resistance means an obstacle for the current flow. Resistance, right? And then the equipment that we are going to be fixing in a circuit to make that obstacle or to reduce the current flow are known as resistors. Right? So these are resistors. Right? Understood now? Resistors. So then we have to talk about the resistors today. That's the last part. See, these are like specific equipment that we are going to be fixing into a circuit in order to reduce the current, right? In order to control the current. That's the main function of the resistor. To reduce or to control the current flow. Right? Understood? So now today we are going to be talking about the resistors. So we are going to be looking through what are the types of the resistors, right? And then how we are going to be calculating the total resistance of the resistors, because resistors also can be connected in two different ways, parallelly and in the series method. So if we take those two also, the way that we are going to be connecting also going to be affecting to the total resistance. Right? So that part is what we are going to be discussing today. So from that, usually MCQs can be tested in a third term paper. Right? Okay, so then shall we go through with that resistors part today?